In this video, we will solve a numerical problem about limiting reagents. Okay, the reaction that we're going to study is calcium phosphate reacting with silicon dioxide and carbon to generate tetraphosphorus, calcium silicate, and carbon monoxide. Alright, the idea here is that we're going to mix various masses of these reagents, and the goal would be to figure out which one of those reagents is limiting, and then what is the mass of this product form. The amount that we're going to mix is going to be 5 grams of each. 5 grams. We're going to mix 5 grams of this. Excuse me. With 5 grams of this. Right, 5 grams calcium phosphate, 5 grams silicon dioxide, and 5 grams of carbon. All right. The way that we're going to solve this problem is to first figure out which one is limiting. And to figure out which of these reagents is limiting, then we have to figure out what is the yield of each one of those reagents in isolation, and the one that provides less yield of our product, okay, tetraphosphorus, then that will be the reagent that is limiting. This is exactly the same as the bread, peanut butter, banana calculation, in which we determined that the bananas were the ones that led to fewer sandwiches. Same thing here, but now we'll have to use moles. All right. So again, the idea here is it's going to be try to go see how many moles of calcium phosphate this mass is, how many moles of silicon dioxide is 5 grams, and then how many moles of carbon. We have 5 grams of carbon, and then using the stoichiometric calculation, figure out how many moles we'll get from each one of those moles of the 3 reagents, and the one that gives me the least product will be limited. All right, so then to calculate the moles for each one of them, we simply have to utilize here the molar masses. In this case, we will be dividing by the molar masses. Okay, so for calcium phosphate, we have that 1 mole is the molar mass is 310.018 grams per mole. Okay, so that is going to give me the amount of moles that I have for calcium phosphate. Okay, and this number happens to be 1.61 10 to the minus 2 mole. Okay, now to figure out how many moles of tetraphosphorus I'm going to get, now I have to multiply this by the appropriate stoichiometric conversion. Notice that this is calcium phosphate. Okay, so I have to multiply. I know that for every 1 mole of tetraphosphorus, we have the 2 moles of calcium phosphate react. Okay, so this is going to give me exactly the yield that I expect if calcium phosphate is limited. Okay, and this number happens to be 8.06 10 to the minus 3 moles. Okay, that is the amount of tetraphosphorus that I would get if all 5 grams of calcium phosphate react, if that is limited. Now we can repeat exactly the same calculations for silicon dioxide and carbon, and I'm going to do them a little fast because they're exactly the same as before, right? I'm actually going to do them all in tandem, right? So I divide this by the molar mass, 1 mole, and the molar mass is 60.08 grams per mole. That will give me the number of moles of silicon dioxide, and then I multiply this by the stoichiometric coefficients. 1 mole of tetraphosphorus for every 6 moles of silicon dioxide, and the yield that I would get out of this is equal to 1.39 10 to the minus 2 mole. Okay, and finally for carbon, I would do exactly the same thing. I'm going to multiply to this side so that I can actually end up in the same column down here by the molar mass. So for 1 mole of carbon, I need 12.02 grams of carbon. So from here I get the moles of carbon, and then I cross the stoichiometric bridge. I have that for every mole of tetraphosphorus, I need to react 10 moles of carbon. Okay, and the yield that I would get from that is 4.16 10 to the minus 2 mole. All right, so again, we've done the calculation of the expected yield of my product of interest, tetraphosphorus, for each one of the reagents. Okay, and we find that the smallest number is this one. Okay, so that means that this is the limiting reagent. Okay, both silicon dioxide and carbon will be in excess. There will be some left over. and all calcium phosphate will react. Okay, so that is going to be the yield that I get. Now the problem is asking me to calculate this in grams. Then the only thing that I have to do is multiply this number by the molar mass of tetraphosphorus, and then I'm set. Okay, so to do this, we just simply do 8.06 10 to the minus 3 moles of tetraphosphorus, and I have that the mass of tetraphosphorus is 123.90 molar mass, grams per 1 mole of tetraphosphorus, and then this number happens to be 0.999 grams. Okay, and again, this is of tetraphosphorus. All right, so here you have an example for the use of a limiting reagent strategy to figure out what happens when reagents are not mixed in the right stoichiometric amounts, and one of them is limiting, the others are left over, how to calculate the amount of product, and so forth.